Section 10.4 is a really straightforward section, talks about operations with series. So this table right here is on page 378. This is provided on your test. So when you see use power series, you could use that table. Versus when it says in the previous section, verify the power series, then you have to verify them by showing. So use, you could use the table. So assuming you have those three here, this is not in the table and I'm not providing that. But I'd like you to look at this and think about it for a minute. If you look at this, you'll notice that they're multiplying by x every time. That makes this geometric. And if it's a geometric series, this infinite sum will be the first term divided by 1 minus r, provided absolute value of r is less than 1. So this infinite sum would be what? The first term. What's the first term on the list? 1 minus, what are you multiplying with every time? R. Isn't r x? As long as the absolute value of x is less than 1, the infinite sum is 1 minus x. So this condition is a must. I didn't add it in there because I wanted to talk about it to make sure that you understand it. So as long as x is between -1 and 1, that's the infinite sum. Just keep that in mind. So here, we're looking at example A. Use series to find the Maclaurin. You don't have to start from scratch and take derivatives. The cosine is right there. So we know this is going to be 1 minus, and the only thing that's going to change between those is the x. I'm going to replace the x by a 5x. So that would be 5x squared over 2 factorial plus 5x to the 4 over 4 factorial minus 5x to the 6 over 6 factorial. And what that would be 1 minus 25x squared over 2 factorial. I don't mind you writing 5 to the 4th. You have a calculator, you could plug that in. And there it is. Done deal. That's all there is to it. Really simple. E to the x cubed, if I look at the exponential, e is provided. And if I look at 1 plus, so that's the part I have to change. 1 plus x to the 1 over 1 factorial plus x squared. So it's going to be 1 plus, instead of x, it's going to be, let me copy that, that would make this easier probably. So assume I have access to this right next to me. There it is. So instead of x, I will have x cubed plus, let me move this down a bit. There. So this will be 1. Instead of x, x cubed plus x cubed squared over 2 factorial plus x cubed to the 4th over 4 factorial plus, the list goes on, x cubed 1, 2, I missed the 3. So that is 1 over 1, 2 is right there, 3 over 3 factorial, 4 over 4 factorial, and the list goes on. Now if you eliminate that out of the equation, ignore it, take it out completely. There it is. That's all I need. all what you have to do now is clean it up a bit and say that is 1 plus x cubed. So the numbers, I don't mind you not simplifying if there are numbers, but the powers I do want you to simplify. There it is. And that's my final answer. Now, if I had x cosine of x to the fifth, I already found the cosine to the fifth. So what I would say with this would be x times, and there it is, 1 minus, actually it's right there, 1 minus, let's go by 5 squared x squared over 2 factorial plus 5 to the 4th over 4 factorial of x to the 4th minus 5 to the 6th over 6 factorial x to the 6th, and the list goes on. And if I multiply that by x, that will be x minus 5 squared over 2 factorial x cubed plus 5 to the 4 over 4 factorial x to the 5th minus 5 to the 6 over 6 factorial x to the 7, and the list goes on. And that would be my final answer. So, use power series, take the table, copy what you need, and go from there. And here, again, let me copy, let me see, do I still have, there's e to the x. I still have e to the x. Very good. So when they say, how about e to the x divided by x? Again, remember that cosine and e and log, all of these are irrational numbers. So when we program computers, we have to take these into account. We're not talking about what we're using this for, we're just showing you how to use them. So the way this works, you will say e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial x to the 4 over 4 factorial, and the list goes on. All divided by x. So all what you have to do is say 1 over x plus x over x is 1 plus x over 2 factorial plus x squared over 3 factorial plus x cubed over 4 factorial, and the list goes on. And that's how much you need. And I have one more to go of those, so I'm kind of matching everything that you come across in the homework. I need a cosine of x. Let me steal that from here. Cosine of x, we know that looks like, so assuming the table is in front of you, so that would be 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial minus x to the 6. Again, all what I have to do is use that table. And that would be 1 over x squared minus x squared over x squared cancel out. X to the 4th over x squared is x squared. X to the 6th divided by x squared is x to the 4th. There it is. Now, something that we need for chapter 11 and 12. We need the famous Euler property. E to the I theta is the cosine of theta plus I times the sine of theta, where I is the square root of -1, and if you square both sides, you get a -1. This book doesn't like I, they use J, which is the same thing. Same idea. So, keep in mind the way this works. So here we are. Now we need polar. Transform the complex number into, from rectangular, this is rectangular, because this, as far as we're concerned, that's the point -1, 1. So this is the x, and this is the j or the I, y. That's always how it is. And graphically, they're not asking us to graph it, but we will graph it. This is always the real, and this is always the complex. Most books call it I, this book likes j. So this point right there is pretty much -1, 1, nothing more. There it is. That's that point. This is all we have to do. We have to figure out, and we did this already in chapter 6, we have to figure out r. We know that r squared equals x squared plus y squared, Pythagorean theorem. R squared equals 1 plus 1, which is 2. Square root r equal plus or minus radical 2. It's positive because that's the radius of a circle. And tan of theta equals y over x. So I'm finding reference angle. I'm ignoring the signs. So where does tangent equal 1? We have a reference angle of pi over 4, or 45 degrees. And what is 45 degrees in the second quadrant? So in the second quadrant, the angle theta happens to be 3 pi over 4, which means I could write -1 plus j or I as the cosine of 3 pi over 4 plus j times the sine of 3 pi over 4 times r. And r in this case is radical 2. So do remember, given x and y, x equal r the cosine of theta and y equal r the sine of theta. There's r, there's the cosine of theta, there's the sine of theta. You could write this as radical 2 e to the 3 pi over 4i. To me, that's an acceptable answer. You could leave the answer like that. I don't mind. That is in polar form as far as we are concerned. So in polar form, you don't have x and y, you have r and theta. If I look at my second example, -2j. If you're looking at -2j, the key is to plot it. That's always the key. -2j is the equivalent of me saying 0x, -2y, 0, -1, -2. This is easier than the traditional because I know the radius is 2. And I know the angle is 3 pi over 2 or 270 degrees I. That's good enough. To me, this is the answer. The book will write a 2 and will write e to the 3 pi over 2 as the cosine of 3 pi over 2 plus j, they like j, I keep on forgetting, sine of 3 pi over 2. And there it is. Done. Now let me just demonstrate really quickly. It's not a big secret. If you work this out, the cosine of 3 pi over 2 is 0. The sine of 3 pi over 2 is -1. So that's really -2j. You're writing the same thing just in different forms, but we need the polar form to find enough solutions when the time comes, along other things. And we have one more to go. C. Again, if we plot this point, this is x and y, sort of speak. So x is negative radical 3, y is -1. Negative radical 3, -1. Here we are. First things first, r. R squared is a -1 squared plus a negative radical 3 squared. R squared is 1 plus 3, which is 4. R equal 2. So I got this to be already 2e. Now I need the angle. Well, the reference angle. If I take tangent of theta, reference angle means ignore the negatives. And if you didn't ignore the negatives, notice what happened. If you say that's negative 1 over negative radical 3, isn't that positive? So using the formula by itself is unwise. And which reference angle gives me 1 over radical 3? 30 degrees, tan of 30 degrees is the opposite over the adjacent. You want to use 30 degrees, you can. I'm going to say it is pi over 6. That's the reference angle. What is pi over 6 in the third quadrant? Isn't that 7 pi over 6? Or 210 degrees? Whatever you like. So to us, that's the answer. We're done. The book will most likely write this as twice the cosine of 7 pi over 6 plus I, the sine of 7 pi over 6. Whatever you like, you could write. And that's all there is for this section.